Thanks to those of you who have joined early. We're just going to give everybody a few minutes to join this webinar. If you would like to introduce yourselves in the chat, then please do. We'll keep the chat open while the webinar is ongoing, and we'll also have the Q&A facility up and running. But we'll just give everybody a chance to join, and then we'll start in a few seconds. Okay, so I think we'll get going. My name is Martyn Farrows. I'm the CEO of SoapBox Labs. You're very welcome to this, the latest in the SoapBox series of webinars. Again, please introduce yourselves in the chat. Let us know who you are and where you're from and where in the world you are. We'll get straight into the demos in a couple of minutes. But first of all, a bit of context and a small bit of housekeeping from me. So those who don't know SoapBox, we're experts in processing kids' speech. And one of our guiding principles is that kids deserve to have technology that is built with them in mind. In education, that means that we serve pre-K right through to 12th grade. So we've got kids as young as 2 years of age using our technology. And we are the speech tech that powers tools and platforms for language learning, for oral reading fluency, for dyslexia screening, for math, for science, and across a wide range of products from reading practice, formative and summative assessments, screeners, diagnostic tools, mainstream, supplemental, and intervention-focused curricula. What we do is we work with our clients to build engaging and powerful experiences for educators and students. And working with our expert education clients is where the magic happens. Because really the key to our approach is that we provide you with the flexibility to apply the technology in a way that best supports the learning activity and needs of your learners. So today, we're really excited to be talking about our newest features to power early literacy. Internally, what we refer to these as short sounds, and they can be letter names, letter sounds, sounding out, custom words, pronunciations. And anybody who has worked with or parented young kids will know that it can be really challenging to understand those very short utterances. So today's feature announcement is not just a significant major technical breakthrough, it's also a major breakthrough in terms of the transformational impact it will have for educators and students and the foundational building blocks of learning to read. These new features will come as standard with our API, and there'll be no customization needed. So, small bit of housekeeping. We're going to run for just about an hour. We are going to demo these new features, and after which we'll have hopefully 15-20 minutes or so for a Q&A. For the Q&A, please make sure you post your questions into the Q&A facility and not in the chat. I will moderate the Q&A and I'll get to as many of those questions as possible. Apologies in advance if I don't get to your question, but just as a reminder, you can always email us with questions or requests to discuss specific use cases at hello, HELLO, at soapboxlabs.com. So without further ado, next 20 minutes or so, Amelia Kelly, a VP of Speech Technology, is going to demo a range of examples of our early literacy activities powered by these new features. And we're also joined here by Brenda McGurk, our head of education product, who spends a huge amount of time talking about these features with clients, and who will share some of those insights. So I'm going to hand over to Amelia now, who's going to kick off the demo.
Hi, everyone, and welcome. Thanks for joining us here today. I'm delighted to be here, and I'm delighted to be joined by Brenda as well, who together as I demo the new features of the SoapBox engine that pertain to short sounds and power activities and use cases for early literacy. Brenda will be helping me explain why they're important, how they can be used, and how she sees clients using them in her lengthy discussions with them. Brenda's very, very, very knowledgeable, and I've learned so much from her by contextualizing some of this technology as well that we build in-house. So please, we may not mention a use case that you in the audience might be needing child voice technology for or using it for. So we'd love to hear about it. Please mention it in the chat. Please feel free to ask us questions in the Q&A. And as Martyn said, we'll get to it at the end of the demo. So I'm going to dive right in here, and I am going to start demoing some of these technologies. So I'll start really by talking about the verification system, the SoapBox engine system that I'm going to demo here before. If you've been to any of these webinars, you'll have seen me demoing this, so this won't be new to you. But I should just reiterate for anybody who's joining us new that we are a back-end company and we power products that are built by ed tech companies. We don't make the front end that, for example, the teachers or the students see. We make the under the hood voice technology that powers these experiences. So what I'm going to show you here is just a front end demo that our engineers built up for us so that we can demonstrate some of these features in a visual way, which makes it easier to explain. So over here are some preloaded files. I'm going to send them to our engine with what we call a target here, which is a word or phrase that we want to search for or that we're interested in the child having said within the file. And over here on the right, some of the results will pop up and I'll talk through them. So I'm just going to play a file quickly to kick off. In this case, and these all hit our servers live. So this is processed live. As I play them, they get sent off to our system. So in this case, the child is asked to say this sentence. And we are going to search in the file for that sentence, and then our system will return a report. And let me just show you what I mean by that.
My first beat, he said, it went in the window and I flowed it.
So the first thing to note is that the child is speaking in quite a natural environment. You can hear a playground noise in the background. I think you can hear a bell ringing. These are quite typical of the places that children use speech technology, whether they're using a reading app and they're practicing, or even when they're in the classroom and they're being instructed by their teacher. There's generally a lot of background sounds and natural environment noise. We've built our speech technology so it's very, very robust to these situations that children generally find themselves in. So here is the target that we search for within the audio file. And you can see that a system has given it 92%. So this is a score that our technology returns and can be interpreted by the user in whatever way they want. The way we return it to the company or client who's using it is by this JSON object. And this would be familiar to any coders, any developers, as it's very standard, very easy to parse. And it's a way that we can offer up all the data points that pertain to this speech file. And then these can be lifted and chosen as required to feedback information to the teacher or to the student. So in this case, what we've chosen to do is color the words and the phonemes in based on the score that they got. So you'll see that 92% is for the full target, but we can also break this down word by word. My and frisbee, etc. And if you go down to, you can see the child read that quite well all the way down, but they did stumble over one word. And this is the one I want to show you. They were supposed to read followed.
Flowed.
And they said flowed. So you can see here that word got 31%. If we look at the individual phonemes that make up that word, you can see that that sound got a score of 1%. Now, this indicates that our system did not detect that sound in the child's speech when the child said that word. Sure enough, all these F, L, O, D sounds, they actually come together to make the word flowed when that vowel is left out.
Flowed.
So our system, therefore, we already know is very, very good at discriminating these short sounds right down to the phoneme level. So what I want to show you today is extra features that we've added to this engine that really focus on those short individual phoneme sounds. So I'm going to show you 3 different ways of interacting with this engine today. The first one is going to be letter names. The second one is going to be letter sounds. And the third one is going to be custom words. For each of these, we also have a pronunciation flag for those situations where you need to be extra specific about which pronunciation you are looking for within the child's speech. So I'm going to dive right in here to demoing those new features. What's especially hard about this from a technological point of view is just that when children are saying sounds that short, they are really, really hard to process and detect. We built our system especially so that it was super accurate on these small sounds. And now we've made these features so that we can help more easily power these different activities that teachers and educators want to have children do when they're on their early literacy journey. So I think we can all think of use cases where a child would be shown a letter and asked to say the letter name.
G.
What you'll see here in the target, instead of just writing the word G, we have specified using this tagging system that's quite like HTML, that we are looking for G, the letter G, only the letter G. So I'm going to go over to our target here, our summary, and click into it. And you can see that the word G was spoken. And we can also see the phoneme breakdown of the word G pertains to the letter name G. And this is as distinct from the letter sound G. Sometimes a child might be shown the letter G and asked to say G and not G. But in this case, they just say G. And I want to actually bring Brenda in now just to talk a little bit about some of the ways that our clients are using this and how this would actually help a teacher or an educator in the classroom.
Sure, thanks Amelia for that. Well, I suppose, as Amelia said, we work very intensely with the majority of our EdTech partners and helping them to integrate. The integration is simple, but making it useful for the classroom is the magic part. And of course, as everybody on the call knows, one of the key challenges for a teacher in their daily routine or their weekly routine is having the time for each child, each student in their class. And obviously, if they're approaching these early levels of literacy, being able to assess and monitor progress of each child, have they mastered this skill well enough for me to move them on? So a lot of our partners, what they're doing is they're coming up with really fabulous support tools for the teacher to either provide that level of practice that a child may need, or to provide the assessment for the teacher to be confident that those children, especially those ones in the middle of the bell curve, have reached that at that level that the teacher needs and wants in order to move them on. So, and it's wonderful because we can see great new ways that our partners are working to make this a joyful experience for the children and an incredibly supportive tool for the teachers. So delivering back, as you said, Amelia, the system returns this highly accurate data and finding ways to surface that to the teacher so that they can then act upon it and take the next step. So that's what we're seeing there, and it's been really successful so far.
And that's a really good point to make there. Like every student could be different. You know, if you have students in a classroom, one could be, you know, let's say you're learning G, the letter, in a group of different letters. And, you know, the child is like mixing it up with some of those other letters in the group. Or, you know, the situation where one particular child might be mixing it up with other letters that sound the same as G. And our technology actually facilitates this by actually allowing you to check for multiple targets at the same time. So we have one built out here where let's say you had a situation where, you know, you knew this child because you could see they're practicing, you know that they're mixing up G with B and sometimes with D. You can actually search for those at the same time. What are the ones that the child is mixing this up with? And you can send in one call all these letters up to our system and get feedback on each and every one. So in this case, the child did say G correctly. So
G.
But you can see here that, you know, G came back correct, but B, you got the E sound right, but not the B. You got the C sound right, but not the S. Sorry, the E sound right, but not the S. And the E sound right, not the D. And so forth for all these different letters. You can see that our system, again, on the very first letter, on the very first sound in each one, discriminates that it wasn't that it heard.
And this is terrific, Amelia, because this is, I'd say it's one of the most common questions that we're asked when somebody's working with a system new. What about those letters that a child can confuse because they sound alike or look alike?
Yeah.
And the power of being able to actually look for that is really, really helpful.
Yeah. And of course, the other use cases that we hear a lot about is spelling, right? We have one example here of a child spelling. So we have specified, again, using this letter markup, all these letters in order. We've asked the child to spell the word take.
T-A-K-E.
That's really cute, that voice.
Yeah.
So we can see again T-A-K-E, and again the phoneme breakdown for each one. We also have a spelling here where the or in orange isn't well pronounced. The child kind of says ow instead of or.
O, O, A, N, G, E.
So you can see that our system again picked up that this was pronounced in a slightly different way. Again, you know, as the technology providers, we're not offering any kind of judgment about what's correct and what's incorrect. There's many reasons why a child might pronounce something one way or another, but our system will just offer up these scores that can then be interpreted by the teacher who's in the context with the child and knows what the situation is. I don't know if you have any examples of that, Brenda.
So one thing that we often are asked about is, say, for example, it's quite common that a child could be bilingual. So they may speak one language at home and another at school. And the letters can sound quite different. They're alphabetically and visually the same, but they sound quite different in different languages. So a child might be carrying over pronunciation from their first or second language into another language. So it's not wrong, but in order to be able to read fluently in English, that might need some intervention to help the child to understand that other pronunciation of a letter. So again, that can be a really helpful thing to surface to the teacher.
And of course, if a child is using technology that is voice enabled to practice some of these things, one of the benefits of having voice technology in a product is that you get this longitudinal information about how the child pronounced something or spoke these particular exercises over time. It's very difficult, obviously, for a teacher in a classroom to keep tabs on, let's say, 30 children at once and any systematic errors they may be making during their practice time. But having that visually served up and offered to the teacher so that they can see straight away over time that this systematic error is occurring, that's something that has never really been possible before on such a large scale. So really that's letter names, and again, using this letter markup. One thing that I haven't showed you here is that we can actually add in a pronunciation tag as well, in the case that a letter may have one or more pronunciations, like the Z/Z distinction between British and Irish English or American English. We actually have a tag that we can add in here that would allow you to specify Z versus Z or A versus A. So if anybody has any other use cases for letter names, please let us know in the chat. Please feel free to ask questions in the Q&A. Brenda, will I move on? Cool. I'm going to move on to the next feature of the voice engine, which is letter sounds, or what we're calling sound out. Again, it has a pronunciation tag that just allows you to specify. So in this case, again, let's take the child in the classroom who's been shown the letter G. And this time they're not asked to say the name of the letter. They're asked to say the sound that you would make if you saw the letter. So the phoneme or the letter sound. In this case, we have specified that we want the hard G sound, G.
G.
And again, you can see that as distinct from the last example where it had a G, E, meaning the letter name G, we now have the letter sound G. And, it could be, again, a situation where they mix up the hard and the soft G. So we can actually specify that here and look for the other pronunciation of G. So let's just call this G soft so we know what we're doing. And that sounds like J. So again,
G.
These multiple targets allow us to distinguish the G from the J. So J was not spotted in that sentence, but G was. Brenda, is this a use case you see often? I see our clients talking about it.
Absolutely, yeah. It's that whole idea of when children are doing that very early level and learning how to manipulate sound, learning what things sound like. But the feedback we've been getting so far is that this is a game changer, to be able to actually allow the children to practice or assess. The information that we get is that quite often the teacher is doing this either in a whole class scenario or groups. and they're modeling for the children. They're doing quite playful forms of teaching with the children. But again, being able to spot, has every child in that group or in the class mastered this? They may look like they're making the right sounds, but are they? And if they were asked, could they repeat that sound? In a way, this is almost an out of context thing to ask a child to say, we don't know if it's G or J, G or J, because we don't know what context it's in. But to be able to actually assess that, and for the teacher to have the confidence in the system and say, yeah, I'm happy to move the class along now. So yeah, we get a great deal of excitement when people see that we can actually do individual letter sounds. It's just, I really believe that it's going to be a huge help to teachers in the classroom.
Great.
Yeah.
And then, of course, the next step of that on the literacy journey for these young readers is that they are asked to say them in sequence as they decode a word, right?
Yeah, so they're actually then applying what they've learned. So each stage is moving up to, from acquisition then to applying and mastering these skills as they go along. So then they're learning how to either put sounds together to make a word, swap sounds out to make a new word, take sounds away to make a new word, etc., etc. So, which obviously is, I see it with my own son. He'll see something on the TV. It was a manatee the other day, and he'd never seen the word before, and he was going, and I could see him. I was like, oh, he's actually decoding that. That's really impressive. And he said, oh, I've heard of this. Then he was like, oh, I know that animal. But he didn't know the word when he saw it first. So, again, this is the sort of skill that a child then can take out into the world, as well as when they're reading a book. So, yeah.
Fantastic. Yeah. So like what we're trying to offer here is just a way of educators, education companies, edtech developers, whatever activities that you want to employ to help children practice reading, to assess them when they're reading. We want to offer the features that help you do that. So take the sounding out. Take is actually the example I have here as well. Earlier on, we spelled it out using letter names. Now we're going to sound it out using letter sounds.
A.
So you can see here again the phoneme breakdown of each individual letter, but all you have to do as the developer or the coder here is to use this sound out syntax that allows you to, that basically tells our system to don't look for the word take where everything's blended together like an adult saying take. Do look for these individual phonemes being spelled out like that. And, again, it's important that this is really accurate as well, right, Brenda?
Absolutely, because when you think about it currently, the only way a child can be assessed is for the teacher to, at the moment, is for the teacher to sit with the paper exercise and go through that child by child, student by student. But in providing a solution, as you know, it's just so important that that accuracy is as good as what the teacher would do in an observed situation. So we're just really, really happy with the level of accuracy and how efficient the system is as well in returning those scores. So so far it's just been fantastic in the huge amount of testing that the team did over several months, looking for every possible way a child might respond to that, so for example, our Lighthouse customers were fantastic in giving us examples of here are the kind of activities we would want to use, here's how the teacher might use it, and here's how a child might respond. Mm-hmm. So we pulled together all of those, and the team were just fantastic in terms of testing to make sure that it was at a level that we were happy would support every single student in the classroom. Yeah, so highly accurate, highly efficient, and highly flexible.
Yes, absolutely. Yeah. No, it's a testament to the team here at SoapBox as well that they've made this work so incredibly well. And as you say, they tirelessly picked apart all the possible situations. But, getting that accuracy again on really short sounds is difficult because they do sound very similar to each other. And I have an example here that kind of showcases this. The child is asked to sound out the word treasure. And if you focus on the zh sound in treasure, it's one of the least common English phonemes. In this case, the child actually pronounces a j, which is a different phoneme, j, rather than j. So I'm just going to play this, and you can see that our system picks up on that accurately. You can see here that the j sound was actually pronounced j, and our system rightly gave it a lower score. And again, you know, we're not making any judgments here. There are many reasons why some pronunciations would differ, but again, you know, this kind of score that's fed back to the teacher, whether it's presented to them on a dashboard or any other way that the engineer chooses to take the data points from this very rich JSON object, they can then, it can just flag it earlier. You know, you'd be able to see quite early on if there's something systematic going on, or if there's something to watch out for. There's some word that the kid is just struggling with and would need to practice more. So that's what makes this very, very powerful. So yeah, just to summarize then, the letter sounds, or the sound out feature, is the second feature. I've shown you letter names, I've shown you letter sounds. So we've one more left to get through. And again, if you've any more use cases that you'd like to talk about or ask about, please ask your questions in the Q&A and we'll get to them at the end of the session. So the next thing I want to show you is, I actually think this is really, really exciting, custom words. So it just kind of fell out of our talks about how we can make this technology better for the people that are using it and for the different use cases that they have. And you know, one of the things was that sometimes when you've got phonemes, for example, and you're saying one phoneme and then another, and then you ask the child to blend it together, you make something that is like a syllable consisting of several phonemes, but it doesn't make up a recognizable English word. Another thing we found is that, like, in a lot of kids' stories, there's made up names, there's planet names and alien names and dog names and cat names, and they, again, aren't really dictionary words. If you use regular off-the-shelf speech recognition, it will never be able to return that word because that word isn't in its word list, in its dictionary, it isn't in its language model. So this is what we've done here, is made it possible for you to search for any sequence of phonemes in the audio file, and you can make it up as you go along. There's no need for us to tune it. There's no need for us to add it to a dictionary or a word list. It will just allow you to search for it within the audio file. So I'm going to start with the made up word yat. So here's the syntax. Again, it's custom word. And again, we have this pronunciation flag. With custom word, the pronunciation actually is a mandatory flag because we need you to tell us this sequence of phonemes. We have a pre-selected list of phonemes you can choose from. And if you put them in order, this is y, a, and t together, it's going to look for those phonemes blended together, not like sound out where they're separated out, but where they're blended together and co-articulated to make a word. So in this case, yat.
Yat.
And the child says yat. But, you know, equally, you could be looking for, you know, yacht or yote or something. Yacht is actually a word, so I'll try yote. And the child could say
Yat.
And you be able to see that they mispronounced it because, you know, you were looking for this O sound and they said an A sound.
Yeah.
So this would come back low scoring. So this is great because it's infinite. You can make up any word at all. And it can be as long as or short as you want, and we can search for it within the audio file. So, you know, all I can think of off the top of my head now is names like Yat and Nerb and all the other ones we have there. But Brenda, I know this is like a really common use case, right?
Really, really. So at those stages where you're trying to decide if the child is actually applying their skills to decoding new words, if they're common sight words, they may have learned them or they may know them on sight. So it's very difficult to tell if they are actually decoding. So by using what some customers call nonsense words, some call non-words, some, you know, there are lots of different names that are used for these, but it was a somewhat painful experience for customers. We always helped them when we were able to do it, but this completely puts the power back into the hand of a customer to decide what they want to do, when they want to do it, and it instantly updates in the system. And it's a unique feature and it's incredibly powerful for a customer to be able to do that. and extremely accurate as well. We know because we've tested it on some very scary non-words that I struggled to pronounce properly. So yeah, it's just the feedback we've gotten on this as well has been, oh, this is such a useful thing to be able to do this in real time and able to use it with ease. So it's been great. And as you say, it's an extremely common use case. So it's really great that we can meet that need.
Yeah.
Yeah.
And actually, one thing I just thought of there, which I hadn't thought of before, was in English language learning as well. Sometimes there are pronunciation errors that are more common to children who have a particular language as their first language and they're trying to learn English. So native Spanish speakers might have a certain type of error that comes up a lot for them. Native Japanese speakers may have another type of error that comes up a lot for them when they're learning English. And in order to detect it, you need to look for different phonemes in and around the word, and you can just create that with your custom word and see if that is the particular error that they're making. So that's really powerful as well.
Yeah, that actually is incredibly useful. And then the other experience that we're seeing, which is I think a very exciting one, when you've got a full curriculum and a full corpus, to be able to identify common errors and then link that back to earlier stages of learning, so that you're really enabling the educator to intervene in a very specific way. You're not telling them what to do. In some cases, if our partners have that full map back, you can use an adaptive system to do it. But to be able to surface that kind of data to a teacher, whether it's that a particular student has a consistent problem, map them back to this earlier skill, or this group of students are showing this problem, so the teacher can then differentiate for those students. So it's actually very, or choose not to, because it's something that they're going to address in the next lesson anyway, whatever. But it's incredibly powerful in that way. Again, teacher time is so precious, and they want to spend their time on instruction rather than trying to figure out the individual items that they may need to address. So being able to surface that in a helpful way is really powerful.
Yeah, and I mean, the other thing about this is that pronunciations go in and out of fashion and they change. Hearing people here say vehicle sometimes rather than vehicle, and where our system can actually spot multiple different pronunciations of a word. If you just wanted to specify one, if you wanted to spot tomato rather than tomato, this will allow you to do that as well. And the final example I can play for you here is blending, which is another use case of this I mentioned briefly at the start there, when you've got your, like X is made up of the phonemes k and s. And when you blend them together, you can label it with the label X, but really it's two blended phonemes. And you could choose to blend any type of phonemes together, like B and L makes bl. And you could have like different parts of a word. When they blend together, they make a full word. But if you wanted to separate them apart, they could make two syllables that aren't in their own right and their own word. But this will allow you to do that as well. So there's x. I've got the K, the K sound and the sound. Given it a label X, we've called it a custom word pronunciation. And there you go. Of course, if you use letter name for this, it would have the pronunciation X rather than the sound X, which is a blended set of phonemes. And I think of another one there for qu. So you've got the k and w together. So if you were to put that in a dictionary, it wouldn't be there with that pronunciation. So this is why we need to use the custom word pronunciation for any of these blended syllables that you might be coming up with. So Brenda, do you have any other activities or use cases you want to talk about that we haven't covered?
I can't think of any. I think we've covered letters, multiple letters, spellings, sound outs, letter sounds, and blending, decoding, all of those kind of skills. We already had the function for sight reading, so this is the bonus material into the product with these new features.
Yeah, great. I think we covered it all there. Yes. So like all we've done here is that we know about these activities that our education partners, that our clients are using, and that they want to be able to facilitate and use better and use more easily. So we've come up with these 3 different ways of interacting with our engine: the letter names, the sound out, and the custom pronunciation. And we allow you to specify a pronunciation in each. So I really think, we've really unlocked a lot of these different activities, and hopefully we'll be able to support new clients and new use cases from our current clients as well. And again, anybody has anything that we missed, we haven't talked about it, please raise it in the Q&A and we'd be happy to address it. So yeah, I guess I'll hand back to you, Martyn, for Q&A. And yeah, it's been a pleasure to share this demo with you. Thanks.
Thanks, Amelia.
Great. Thank you, Amelia. Thank you, Brenda. So we do have quite a few questions, and I'm going to try and group them together. So if I don't read specifically your question out, just know that if I'm in the right ballpark, then I'm just using an example. So we have here a question about accents. So you mentioned different pronunciations of letters or sounds. Can you accommodate different accents? If so, how do you do that? And in a British context, for example, you might have a short A sound and a long A sound in the word grass. So I say grass, lots of people say grass. Both would be correct. How do you handle that?
That is an excellent question, and one we talk a lot about in-house here. So we have different ways of dealing with accents. One is that if they do have a phoneme difference, we have multiple dictionary entries for that, so that if a child says one rather than the other, we are able to return the phoneme breakdown for whichever one they said. Now with our ability to specify pronunciations, if you just wanted to look for one and not the other of those pronunciations, that's now possible using our custom word feature. We also, we built our models on loads and loads of different accents, hundreds of thousands of children from 193 countries. So our system has learned that there are different ways of pronouncing the same thing that are equally valid and equally acceptable. So that's reflected in our technology as well.
Great. Okay, another question from Mosa. How much of background noise level can the system tolerate? Difficult question to quantify maybe. So acknowledging it's a difficult question, but asking it anyway.
Yeah, it is quite difficult. We do a lot of noise testing. So first of all, again, the training data we use in our models that underpin the system have been taken from real world environments. So we don't use audio files of children in quiet environments with headset mics. Instead, we use children out in the wild doing their thing using mobile phones and tablets. And all of that gives our system a natural robustness to those types of environments. Having said that, we do tests specifically on noise as well. So any tests that we have, we actually infuse it with noise from different types of noise: classroom noise, living room noise, playground noise, at different signal to noise ratios between like 10, 15, 20 decibels signal to noise ratio. So even like when it's quite difficult to distinguish from the background noise, our system can do quite well in those situations as well.
And on a related question, I've just lost it now. Hang on 1 second. Where's it gone? How do you account for words that have multiple pronunciations? So like red and read and aunt and ant, for example.
So yeah, there are some pronunciation differences that don't change the meaning of a word, like tomato, tomato, but then there's those ones that do. So read and read look the same, like READ, read and read, as in the past and present and past tense of read. So if you read, if you're asking a child to read a sentence and the context makes it ambiguous as to which one you mean, you can use our custom word pronunciation just to specify that you want the read, for example, and not read. So in that case, that's something our custom word pronunciation can help you with.
Great. Okay. And on a related question, you see how I'm linking these together. Could this custom word pronunciation be used in the future for identifying code switching, for example, using words from heritage languages in child storytelling? For example, a child using words from an indigenous language in an English story. That's from Lane Hubbard. That's
a brilliant question. I love it. We're thinking about this in-house a lot as well. One of the kind of things that happens when you can specify any string of phonemes is that you can put them together to approximate a word in a different language. Now, there are caveats here. different languages use different phoneme sets, and even when they have the same phoneme label, sorry, the pronunciation of that might be different in that language because of just, you know, geographical differences, accent differences, and the other types of phonemes that they're coupled with. That said, if, you know, we borrow words all the time. If I were to use a word from the Irish language, I'd probably have anglicized it quite a lot when I say it. If you used our custom word pronunciation to search for that Irish word in my English speech, you would be able to find it by putting together a string of phonemes. And that would be true for any language as long as you can approximate it using our phoneme set. So yes, I think it would be very, very useful for code switching, especially for underserved languages as well that don't have a lot of speech technology resources.
Great. Okay. We have a question here from Mary Eisel, who I know is known to both of you from McGraw Hill. Shout out to Mary. Can you speak to the validity of the confidence levels as compared to teacher evaluation of the same task? So human assessment compared to the machine assessment.
Yes, this is also an excellent question because, you know, I realize we demo a lot of this stuff, but, you know, what we haven't really talked about is what would a teacher do in that case? Does a teacher always agree? We do have a lot of internal testing that whereby we compare what our machine says to what human annotators would say. And we find very, very high correlation. We will be hopefully putting out some results about this in the near future. So keep your eyes peeled for some more detail on that. But just to say that both in-house testing and independent benchmarking by our clients and by independent researchers have found that we correlate very, very highly with human assessors in all these regards.
Right, we have one here. I'm going to pick one out here because Brenda's sitting there not answering any questions. I feel like she's getting away with a lot. So are there examples, this is from Jody, are there examples of front ends, or can you talk to examples of front ends that other companies have built that you can share with us? So we can't share them, but maybe you could talk about a couple of examples of people that have integrated, maybe not these features because they're brand new, but other technologies like Linguini and so on into their product.
Absolutely. So we have lists and lists of customers who successfully integrated our Fluency feature, where that feature is returning not just a transcript of what a child read, but comparing that to a prompt text and returning the kind of data that a teacher would have to do if they were observing and marking. So for example, substitutions, deletions, repetitions, and we're really excited because we're just working on a new round of self-corrections as well, which really brings it much closer to the teacher observed system. And that's been used successfully for several years now, and we're continuously refining that also. But with regards specifically, we've loads and loads of customers using verification for everything from, Amelia quite rightly pointed out earlier, language learning, so vocabulary acquisition, etc., and short sentences, to the early levels of literacy, going through from learning vocabulary to putting together and reading, say, early decodables, etc. But with regards to the short sounds, it's a new feature, but we are already working with 3 customers to integrate this feature, because one of the reasons we made it was because it was so badly needed, and it was in response to a requirement from customers and from the educators that they serve. So they were sitting ready with items that are currently either done on paper or digital assessments that a child may use in MCQ, etc. And what was missing there was a magic element of voice. The child can recognize, the child can hear and click, but can the child hear and repeat, etc. So it's brought that whole new dimension in. So yeah, actively working with 3 customers at the moment who I think will launch to market very soon with those updates. So I hope that answered the question.
Great, thank you. Question from Tom. Hey, Tom. Tom's in San Francisco. I know Tom. Tom builds edtech tools which provide real-time interaction. With the leap forward in phoneme accuracy, how quickly do you get a response? I mean, that's an easy one for you. How long is the processing time?
Very, very, very quick. Although I can't remember the figure. I think it's like a few hundred milliseconds, right?
Yeah, I mean, we were demonstrating a live system there, so you were seeing how quickly the responses were. So I think it's certainly less than 500 milliseconds, particularly for those short sounds, maybe 100 or 200 milliseconds. Okay, let's go for one that's got a little bit more of a tricky one. So from Roisin, Roisin Maguire, really remarkable features being demonstrated. Just wondering, in a global context, if a child is being taught in a language other than English, can the voice engine adapt to that? So I guess non-native speakers of the language.
So if the system itself is in English, so if the child is speaking English, it doesn't matter if English is their first language, if they're an English language, I need to learn some English myself, an English language learner, they should be able to use our system just fine. If we're talking about our system working in other languages, we do have a language agnostic backend. So we have built out our system so that we can build in a new language by just dropping in a language pack into our current setup or our current architecture and infrastructure and build that language quite quickly. Now, what we would want to do is extensive testing before we put it in the hands of our clients, but in-house we would be able to build out in other languages quite easily.
Very good. Okay, so does the system require going through a voice calibration exercise before starting each activity, for example, by having the child count to 5 or repeat a sentence? How does the system calibrate for voice and accent differences?
So the system doesn't need to calibrate. The system is built on so many different voices that it has learned, and using the sophisticated ways we model these voices, it has learned what is acceptable pronunciations of various different things. So like a good analogy is a self-driving car, the way that they're taught to see the world and react to it. If you trained a self-driving car around and round in a circle and then put it out on the road, it would not have a very good time. However, if you showed it many situations of country roads and cities and corners and roundabouts and all those kinds of things, then it would be able to drive itself around. And it's the same with training any kind of artificial intelligence. If you're training your model that models speech, you just need to show it a whole pile of different accents and dialects. And then you don't need to tune it. You don't need to say, well, here's a child and this is the way they speak, so now work towards this. It should be able to work for everybody equally because it's seen so many situations already.
Okay, I have a good one here. So from Ursula, Fluency component still needs to have the text pre-processed ? Or is it possible, I think this is about multiple targets, Amelia, is it possible to send random sentences to be evaluated as was shown in the first demo in the beginning of the presentation? So I think that's about multiple targets.
Yes, it is. So when we focused on the short sounds here, you're right, we were only looking at individual words, very short sounds, but any of those could have been phrases as well. So actually, when you take the spelling, it was a sequence of letter names, or when you took sounding out, it was like a sequence of, it was looking for a sequence of phonemes in a row. So that's essentially like a phrase. But yeah, if you put out many sentences, you can put up to 50 at the same time, and it will search for any and all of them within the audio file. So you could use this for voice search, for example, or any kind of accessibility. If your options were up, down, left, right, jump, turn around, they can be words or phrases, and there can be up to as many as 50 that you search for at the same time. Then based on the score that's returned by the system, you can then trigger an action based on the high score you get back for one or several of the targets.
Excellent. Okay. Cheryl's question is, I think, about acoustic models. So is there a calibration that takes place for each child? I'm trying to figure out how it could filter out close proximity but irrelevant background noise. For example, the teacher sitting next to the child giving feedback. Yeah, so really the verification element of this this way of interacting with the engine, where you're searching for a word or phrase, we can, if the teacher is talking and the child is talking, but then the child says cat, and you search for the word cat, it will ignore all the rest of the audio and just search for that individual word or phrase. So that allows you to be very focused in what you're looking for within the audio file. And it's in fact why we built it this way. We found that people who were using just normal speech transcription
tools. They were looking at the text that came back and it was a child saying a whole pile of stuff. And they're like, right, but did they read the word cat or not? And then they'd have to build more logic on top of that to try and search in that for the word cat. We've just married them together and they do it all at the same time.
There's an interesting one from Hamish in the chat. How does the system cope with children who have speech language disorders and or impediments?
So this system can be used for anything that our clients and educators decide to use it for. If a child has a speech disorder where they have trouble articulating particular words or phrases, likely those phonemes, those words will come back with lower scores than the other ones. So really it's up to how the clients design the tools that they want. Brenda, you know we work with people who are working on speech and language disorders.
Absolutely. So we do have some customers who are applying the technology to support children with speech and language development issues, whether that's for practice or for assessment to benchmark the child and see what kind of intervention and therapies they may need. As most of us know who have had to do any interventions with children, you go for an hour with a specialist and then it's up to the parent or somebody else when you go home to try to work through that. And it feels like work for the child. So there are some amazing apps coming out and programs coming out that support children in these situations where there might be a specific sound or specific method that you want to assess for, see if the child has that issue. There are common pathologies, as they're called, that can be assessed for by using our custom pronunciations. So if children typically mispronounce something in a certain way, it may indicate a particular pathology, and then speech therapists have the expertise to know what kind of practice should be put in place to help to resolve that if it's needed to be resolved. So we've got some very exciting applications, and as you said, it's about telling us what you need to do with it, and we'll help you figure out how to apply the system. But for most people, like speech and language therapists, the minute they see it, they know what they want to do with it. They actually require very little support to go and do it because they're so ingrained in the linguistics of it. But yeah, 2 very successful programs at the moment have integrated for speech and language.
Okay, so Anton has a question about pronunciation. So a New Yorker might pronounce, I'm going to pronounce this wrong, but I'm going to try, Anton. A New Yorker might pronounce yawn as yawn. Without calibration to the speaker's voice or accent, how can you judge that as incorrect or correct?
So I suppose the important thing to note here is that, being on the back end and the provider of the technology, we don't actually say whether something is correct or incorrect. We just offer up a percentage of how likely that pronunciation matches the model that we've already built up. So if we have a model where we have New Yorkers saying yawn as yawn, and we have people from all over the world saying it in various different ways, we build up a model of that particular phoneme where all these different things are acceptable. So much like a human does it. So when you hear somebody saying one thing or another, you're able to understand that just because they pronounce it differently from you, it doesn't mean it's not equally correct. It's just a different way of saying it. And actually, I think there was another question there that has the same answer by Anton as well. So Martyn, if you don't mind, I will answer this one as well, where you asked Anton about dealing with different acceptable pronunciations for a phoneme that has many different allophones. And I think you picked one of my favorite examples as well for the T sound. So T has loads of different ways it can be pronounced. It can be like a T, or like in Ireland, when we use it at the end of the word, it sounds more like a sh sound, like night and right. It can be pronounced like bottle, like a glottal stop, or a bottle, or like it can be a tap. It can be all these different things. When we build up our models, we don't just get people saying phonemes in isolation. We have that T sound occurring in all different words, in the middle of words, at the end of words, in all their different cloaks, be it their glottal stop situation, their aspirated situation, their lenited situation. And again, we build up a model of a T in context that has all these different kind of acceptable ways to be. And if a child is pronouncing something and they're saying it in a way that a human can understand it, likely will score high for that particular word, because we've already seen it happen because our training set is so vast. So I hope that went some way to answering the questions there about pronunciations, be it accent-based or just allophones within normal words.
Okay, so I'm conscious of time. We've got 6 minutes left. We'll try and get through as many of these as we possibly can. Actually, we have a question here from Gloria. I'm guessing that's Gloria for Amplify. Hi, Gloria. Exciting announcements. Does this now allow the system to be able to guess the word the child actually said if different from the target word, maybe based on the recognized phonemes that are strung together to guess the actual word the student said?
It's like you have a crystal ball, Gloria. No, it's not there yet, but this is exactly where this kind of thing is going. So once you know, you can see that we can recognize a string of phonemes that could go together to make up any word. It's really interesting, the kind of flip side of that, which is if the child says something like, I showed an example there where the child was supposed to say yeah or yacht or yote, and they said yat, and you could see the O sound scored very low. But the next obvious question is, well, what did the child say instead? What we're offering sometime in the future in our roadmap is that we're going to be developing a feature called Sounds Like. So we'll be able to show you what other sounds it sounded like. So the child obviously didn't get there, it scored very low in the sound that the child was asked to say, but maybe it scored high on some other phonemes. And once we have that, we can start piecing it together, and who knows where it's going to go, but it's going to be somewhere very exciting, and it's going to facilitate a whole new host of use cases and activities.
So a couple of tricky ones to finish off with. So Beatrice is asking, how does the user know exactly what to type in the targets? So in other words, is it documented anywhere that how you actually construct the query that's sent to the system with the list of targets?
Yeah, absolutely. So I didn't show it there because just it's in our documentation, and again, our demo there that the engineers built up, what's happening under the hood is just a simple HTTP request, like a curl command where it says target equals whatever in a big list, and then the audio file, and that's sent to our system. It pings off our API, and you get that JSON object back. So we have that all completely documented. We can send out our developer docs, and you can have a read through them, and you can see just how easy it is to integrate and interact with our system.
I'm going to take this as the last one because it's actually quite an interesting one. So it's actually about the scoring, the underlying scoring. So it's from Carolyn, and it's about the sounding out of where we did take and the sounding out of to ache. Why was the score at 94% rather than 100%?
Oh yeah, okay. So again, 100% is probably what the teacher would give the child if they said it that way, because they got it correct. The number that our system gives back is an acoustic model likelihood. It's how well that child's pronunciation matched one that was learnt by our system before. So when we say 94%, you can take that as high. It doesn't mean necessarily that it's any better than 93% or any more accurate. It's just that it matched our model with a very, very, very high confidence is a message you can take from that 94%. And then you can use that to feed back to the teacher or the student in whatever way you like. You saw that we chose to show things that were above 60% all in green and things that were below 30% all in red. But that would differ. That could differ not only per use case, but also it could differ per student, and it could differ per phoneme per student. So for example, if you know that one of the students pronounces something or is having trouble pronouncing something in a particular way, you want to encourage that student to continue on, you may not want to stop their learning or the practice every time they hit on that thing. You might lower the threshold and allow that child to continue on without getting any kind of discouraging feedback at that time. Again, it's entirely up to the user. All we do is offer this number that shows how well the audio file matched our model of what that audio file is based on what we've trained on.
We do have time for one very quick one. So are any specific headsets or specific equipment required? Yes or no?
No. Absolutely not. Again, everything is trained on kids using tablets, mobile phones, acting normally in the environments they usually find themselves in.
And on a related question, if it's a cheap tablet with poor audio capture, can that impact performance or efficiency?
If the file isn't recorded properly and it's damaged and we can't really hear it as a human, it won't work. But if you can hear it as a human and you can send it to us in the WAV format, then it will be absolutely fine.
Okay, so we've come right up against time. We still have over 80 people on the call, so thank you all for staying until the end. We really appreciate it when you're on different parts of the world, on different time zones. I would particularly like to thank both Amelia and Brenda for an excellent presentation. And please reach out to us, hello@soapboxlabs.com, if you have any further questions, and the recording of this will be made available. Thank you so much, everybody. Bye-bye now. Enjoy your Thursday.
Thanks, everyone. Bye.